Welcome to Eureka, and we are going to have a really interesting and engaging conversation with Dr. Navin Khanna. He is a senior scientist and also a group leader at International Center for Genetic Engineering and Biotechnology at New Delhi. We are going to talk about dengue and the kind of work they are doing, the kind of instruments with which you can deduct from hepatitis B to HIV. We are going to have a lot of very interesting discussion, but before that, let's take a quick look at his brief profile. Keep watching Eureka.
Dengue cases have dramatically grown around the world, and India has 50% of the global population that is at risk from dengue. Early detection of dengue can save many lives. For the last 17 years, Dr. Navin Khanna has been working hard to discover ways to combat dengue. Dr. Navin Khanna is presently senior scientist and group leader of the recombinant gene products laboratory at the International Center for Genetic Engineering and Biotechnology in Delhi. He is also an adjunct professor at the School of Medicine, Emory University, Atlanta, USA, and adjunct faculty at Translational Health Sciences and Technology Institute at Faridabad. Dr. Khanna did his MSc from University of Lucknow, Department of Biochemistry in 1977. He holds a doctoral degree in biochemistry from All India Institute of Medical Sciences, New Delhi. Dr. Khanna moved to Canada and worked at the University of Calgary for 3 years from 1984 as an Alberta Heritage Foundation Fellow. He has been instrumental in developing novel recombinant designer proteins as inexpensive, highly sensitive, and specific diagnostic intermediates for viral infections. One of his very promising projects was dengue diagnosis kit named as Dingy Day 1, as it can detect dengue infection from day 1 of fever and can also tell you fever had a dengue infection. Most importantly, all the 4 types of dengue virus that cause dengue are being taken care of in the project. After developing a test kit, Dr. Khanna acquired an international patent on the world's first drug to combat dengue, SIPA. Dr. Khanna holds more than 5 patents and has transferred the maximum number of technologies to the industry in the country. He has been honored with several awards, including the Biotech Product and Process Development and Commercialization Award. As a dedicated researcher, Dr. Khanna has published more than 100 research papers and 5 reviewed articles in national and international journals and books.
Thank you, sir, for being with us. It's a very interesting opportunity. I saw your institute. Lots of interesting work is taking place. I'm sure this is one institute which is going to take India to 21st century and also make us a world leader, global leader in science and technology. Let me ask you this question. I mean, dengue is an area that you have been working for quite a long time. Dengue is also a disease which is caused by malaria. Caused by mosquitoes, which is also responsible for malaria. How different are malaria and dengue?
So, there are 2 different vectors. So, one mosquito would only transmit malaria, while the other mosquito will give you dengue, but it can give you chikungunya. It can also give you Zika.
Okay.
So, there are different mosquito population for it.
And how different are these mosquitoes, like in their behavior or other things?
So, malaria mosquito lives in like dirty stagnant waters, and it has a big flight range. It can fly several kilometers.
Okay.
Dengue, on the other hand, is a very lazy mosquito. It only breeds in clean water, and its flight path is about maybe 150 to 200 meters.
Okay, that's all.
That's all.
So, which means that if you are going to get dengue, it's going to be because of some clean fresh water somewhere stagnant nearby your
nearby, either your office, workplace or home place. So in theory, that most of the time we keep blaming government that they don't control dengue. I think public has to look at it, that you just ensure that about 200 meters surroundings you do not have a fresh clean water open, which is breeding site for these mosquitoes. It's not very difficult.
There's a very interesting point. One of my friend, when I told that I'm going to come here and going to talk about this, asked like, malaria we have been hearing for hundreds of years. Okay, but dengue, almost none of us heard it, let's say about 15, 20 years ago. How is it that it's become such a major disease, spreading all over India, causing huge discomfort and problem?
I would say urbanization, and global warming. It's ensured that, as I said, that the population density has increased. So initially, if the mosquito, let's say, took the virus from a human or gave the virus to a human, then it goes to another place. There is no human in 150 meters.
Okay, because now, it can go only up to 150.
Yes. So now you have so many population density, it finds the host and transmits. And wherever you have urbanization, more roads goes towards that side, so the mosquito goes along with these vehicles to other places. So the spread of the vector and the population density along with this global warming, I think, are major factors for dengue.
Okay, how do you distinguish this dengue vector mosquito? I mean, is there any specific features?
Yes, it's very simple. It's very simple because it's known as tiger mosquito. It has white stripes on its legs. It's mostly considered a day biting mosquito, so you would have that early in the morning, daytime, and in the evening. Okay. And it's very, so if you kill it, if you see the white stripes, it's a dengue mosquito.
Oh, okay, fine. Roughly the statistics, like kind of official statistics say that about 30,000 people in a year are affected in India. But whereas many other people also put it like something like 10 times more than that. And the global effect is something close to about 30-40 million.
Yeah, so I would say you're absolutely right that dengue is underestimated, reported in India. Now the trend is changing. Sri Lanka reports 60 times more dengue cases than India.
Okay.
So some of the figures you said 30,000 a year, now people are saying no, it's about 10 times, but I would say maybe it's about 1,000 times.
Oh, that's a kind of...
If you look at the global publications, they would assume that India is an epicenter of dengue patients. Okay. So unless we fix the fight against dengue in this country, you cannot actually fight dengue from this planet.
Then another interesting point that I also noted is that the kind of reporting that comes from, let's say, southern India about dengue seems to indicate that maybe it's highly concentrated in southern India and maybe not, northern India or colder places like Himalayan region is devoid of dengue. Is that the kind of scenario?
I don't think that is true. Southern India is their health system is very organized. So I know that I'll talk about the dengue test, which all southern states buy as a bulk. So they seem a little more organized. They report. The patient care is a little more recorded. So maybe the reporting is much more from there, but nonetheless, North India, Delhi, you could see in Bhopal, you could see everywhere else. Now you see dengue cases being reported from Jammu and Kashmir, and so I think because of global warming, the vector is now spreading to other areas. So dengue is still a major problem, I would say, all over India.
Okay, this is an interesting point, and then we'll take a very short break. Keep watching Eureka. Welcome back to Eureka, and we are having a very interesting conversation with Dr. Navin Khanna, who is a senior scientist and also a group leader at International Center for Genetic Engineering and Biotechnology at New Delhi, an institution that is supported by Department of Biotechnology, Government of India. Before the break, we were talking about the dengue, its spread, and then how it is resurging in India, and it's become a major public health issue in India and perhaps all over the world. Testing is a very important thing, and then you have done, and your institute and your team has come out with a very cheap and a very easy testing kit, right? So how does it happen? What did you do? Why you went into this, in fact?
So I recall, I think several years back, ICGEB director received a letter from our president, Abdul Kalam, saying that dengue is a major problem for Indian Army and we need to have a dengue test. And I think that was the seed. We started to work on that. And one of the reason is that if you have to make a test, you need well characterized sera samples. You need absolute truth that this is a true dengue sample and this is not a true dengue sample.
Okay.
And I think we did not have those samples in India. But ICGEB is an international organization, so we had students from Sri Lanka. Sri Lankans have put dengue on their top end since 1970s. So they had all the well characterized seras. So I think that was very important. That was one part of the DNA. The other part of the DNA was how do you make these proteins which will detect our dengue virus infection, or how do we make those antibodies which will detect the dengue virus. And we at ICGEB are very good in making these recombinant proteins of medical use. So we had a PhD student from there, we had a postdoc from there, and the seras are very difficult. You cannot bring human sera from one country to another country, but you can take people from one country to another country. You can take the proteins and antibodies from one country to another country. So one of my PhD student who was working on this, he would make something here. To test it, he will go to Sri Lanka. Right? After testing, he'll come back, look at it, is it true or not, then make some modification, go back. So this was several years of work. So we had a prototype dengue infection, and what we realized very early on after talking to clinicians, that in India, you could get dengue several times because there are 4 viruses of dengue, 1 or 2, 3 and 4.
Achha, there are 4 types.
Four types of dengue, and each one of them can cause severe disease. And the trouble is that if you just had one virus, your body will take care of it, you are protected for life. But since you have 4 viruses, these viruses, if you get a secondary infection with a different dengue virus, you are in trouble. That's called a secondary dengue, and secondary dengue cause more hemorrhage, and you could have dengue shock syndrome. You could lose a patient very quickly.
Okay.
So for a clinician, this was also very important. First thing, is it dengue? Yes or no? Is it primary dengue or is it a secondary dengue? So our bar was very high.
Okay. So you don't. It's not just enough that you find that it's dengue.
Yeah.
You have to also find that whether it is the second time that you have got
Yes,
it. It's something like a heart attack. If
Yes.
it is the first heart attack, it's fine. It's a second heart attack. You have to, that's the
could
kind
be
of
analogy.
precision that you need.
Yes.
Oh, interesting.
So, and to do that, you need 3 kinds of markers. One is some pieces of virus which are circulate in your body. You have to detect that. We were able to make some reagents to do that. Then body responds to these viruses, initially by one kind of an antibody which is called IgM, then the second antibody which is IgG. IgG persists for lifetime.
Okay.
And the virus, the antigen comes for few days, and IgM comes for a month in between. So this 3-in-1 test actually picks up your dengue fever from day 1 of fever. But even if you ever had dengue fever in your life, like you are perfectly healthy now, if I take a sample from out, I can tell you if you ever encountered dengue in your life.
Even though I don't know or no medical
Even
people
you are
ever-
normal, you have no fever. If you ever suffered from a silent dengue, this test will tell you.
Okay.
So we gave this technology know-how to one of the Indian manufacturing company which is WHO certified, and this has high class standards, and then they have launched this kit.
I was told that when you presented this kit to that person, there was kind of slightly disbelief that how can it be that cheaper, whether it will be quality of international standard. Can you tell us that story?
So we have been working with this company, and we have transferred know-how for HIV, for HCV, for HBV, for several other viral infections. So we gave them we had a good working relation, we had a good confidence in each other. we gave this prototype test to them, and the owner of the company, Mr. Lalit Mahajan, he was feeling feverish. So they took his sample out, and in 10 minutes they go back and say, sir, you are suffering from dengue. But since he is the boss, you don't be wrong, and this is an unvalidated kit. So this company had kits from other countries, from US, from Korea, from Australia. They did with those tests. They were all negative.
The international ones were negative.
They were all negative
and
on day
picked
one.
up.
Yes, this was positive. So in theory, most people would say this is unvalidated. You are telling me a lie. It's a false positive. But this gentleman, because he had worked with ICGEB, he knew that we don't give them kind of a know-how of inferior quality. He decided to call a technician to his home and did a wonderful experiment on himself. Every day he will take out, the technician would come to his home, he will take 30 ml sample. So now he has 30 tubes over 1 month. Now he asks his team, put all the 4 tests and check. Because dengue you can check on different days by different markers, because it leaves different imprints. Initially you look for the antigen, then you look for IgM, then you look for IgG. So as I said, that our test picked up antigen from day 1.
And that's why he named it as
That's
day
why
one.
he named it as day 1. And then the other test picked it up on day 3. Some tests picked it up on day 4. Then the IgM came, then the IgG came. It was a true dengue. So I think I salute him for believing in what he saw with this test. And and this test now has become a world leader. It has a global presence. It goes to other countries more than.
So instead of importing costly test kits, today we are actually exporting it to,
yes. We have reversed the arrows.
and also to poorer countries. So because of our
Absolutely.
work, I mean, people all over the world can actually benefit out of this.
Absolutely.
Is that right?
Absolutely.
Yeah. I think it's a very, very important and a very interesting story of the Indian science and technology. We need to take a very short break. After the break, we are going to talk about, sure, you have found out that somebody has a dengue. What do you do with them? They have come up with a very interesting botanical drug using plant extract to treat dengue. We are going to discuss about it after the break. Keep watching Eureka. Welcome back to Eureka. We are having a very interesting and a very engaging conversation with Dr. Navin Khanna. This is a very interesting institute. This is an international center and supported by Department of Biotechnology, Government of India. How does this international center came into being?
So I think about 30 years back, when biotechnology was at nascent stages in this part of the world, and more the fruits of biotechnology were being recognized in the western part and the European part of this world, our Prime Minister felt that we need to provide the fruits of biotechnology for developing nation. So I think with that frame of mind, this ICGEB was made, and there were several countries who wanted ICGEB.
Okay.
But I would say that our political leadership was smart enough to have the vision and bring ICGEB to New Delhi. Now that was the time the funding was always a problem, and Italian government said that yeah, we will be able to fund it provided we are also able to have a center there.
Okay.
So that's how then there was an ICGEB Italy, which was the headquarters, and ICGEB Delhi, an institute here. And after about, I think, 20 years of existence, then the need was felt that there should be an ICGEB in Africa. So the Cape Town ICGEB came up. So now we have more than about 70 countries. We have a presence in many of them. Most of them are second and third world countries.
Okay.
Because the rich countries don't like us. We take away their business. So we provide recombinant proteins of medical use. ICGEB has provided several proteins like insulin, hepatitis B vaccine, erythropoietin, GCSF, GMCs, you name it, to several countries, and many of them are in the market.
Very, very interesting. And you growing up in India, studying here, in Uttar Pradesh, and maybe coming for your post-graduation or so in Delhi, and then suddenly going to, let's say, Canada for your higher studies. That should have been a kind of a cultural shock, right? How did that experience change you?
No, I don't think there was any cultural shock. I was brought up by my grandparents, and my grandmother, my hero, she would tell me that if anybody can do anything, you can do it better. So, as a childhood, she gave us all the confidence. And then, of course, the education in biochemistry at Lucknow University was an eye-opener. We came to AIIMS. AIIMS was a big name, and we had world's best teachers with us. And we always had this, human health as an agenda, this attitude of so what next? So, if you could do something for society, that was ingrained at AIIMS. But jobs were very difficult to come by, and this was a tradition. We used to jokingly call them leftists. People who leave India were called leftists. So I applied for postdocs, and of course in Canada I got this Alberta Heritage Foundation fellowship. It was a very prestigious fellowship, and there we started to work on some new proteins, which bind calcium, plays a big role in life and death. We found a new protein.
Okay.
We didn't know the function, but even in that lab, my boss was very nice. He said, this is a new protein, but the known proteins, let's not throw them in the sink. We will sell it to companies, and we take money from them and reinvest in the lab. So there was self-support. I like that attitude. So while we were moving the frontier, whatever is known, you are still harvesting something. And so we had this protein with no known function, and then there was a publication which had come a week before, and my boss brings that paper. He said, look at this, Navin, maybe your protein is the same molecular weight, maybe, and calcium binding, maybe this is the function of that protein. So I said, okay, we'll check it. So lab was fully equipped. Tomorrow morning I go to the lab at 6 in the morning, start my experiment. By 4 o'clock, my head is down, I'm a little depressed. I put my notebook down, and my boss comes. He said, Navin, what happened? I said, no, Dave, I'll repeat that experiment tomorrow because controls didn't work. Control means the experiment which was published didn't work in my hand. He opened my lab notebooks, he flipped through the pages. He said, but you have done everything all right. Call the author. I said, no, let me repeat it tomorrow. He said, no, call the author. So he gave me the phone, and I was being very apologetic. I said, well, we need to take some help, because we were trying to do this experiment which you published. It didn't work in my hand. Oh, he said, we are withdrawing that paper because it didn't work in my hand.
Okay,
So I put the phone down. I hugged my boss. He had changed me forever. He had more belief in me than I had in myself.
Very interesting point that we need to have a belief on ourselves.
Absolutely.
And then do
Absolutely.
carry forward. Now coming back to this issue of dengue, you found a very interesting kit which can detect it from day one. And for the treatment, you are now working on a medicine which is botanically based, right? So how did this story start?
ICGEB had invited Professor Valiathan, and the title of his talk was Ayurveda Call to Biologists. And he said that we have such a gold mine of Ayurvedic knowledge, but it's all traditional knowledge. There is no modern experiments to back them up. And it so happened that at the same time, Ranbaxy approached ICGEB. They said that, you are working on dengue, you have dengue bioassays, we have Ayurveda knowledge, could we kind of work together? And once again, Dr. Bhan, DBT secretary, he kind of helped this marriage, and both of us worked together, and they provided the Ayurveda knowledge, we provided the dengue knowledge. And after several years of work, we came up with a plant called Cisampella pereira, which has the ability to kill all 4 viruses of dengue, 1, 2, 3 and 4 in test tubes or in animals. And then more recently, and we have patent in 17 countries on this, we have signed an agreement with Sun Pharma to provide a botanical drug against, world's first botanical drug against dengue, We want to take it through Ayush route, so that probably it will go faster. But the Sun Pharma has plans, because to have a global footprint, they also want to pursue this through a US FDA route.
Okay, so this is in the kind of product making stage.
Yes.
That is, the research work is almost
I would
complete.
say the lab validation is over. Now for commercialization, there are different steps, in the sense that you can't pick up the plant from anywhere. You have to make sure that it is the right plant. So where do you harvest, how do you harvest, do you have enough supply chain of this, where do you dry, how do you make the extracts. So those logistics and permissions are being taken, and then the tablet would be formed, and then you have to, once again, although it's Ayurveda based, you still have to check the toxicity in animals, because Sun Pharma is using this as a modern medicine. So they would go through all the filters and then do the hopefully clinical trials, and provide it to people. But you can imagine the impact of a tablet, how much scare it is there when the dengue season comes, that would disappear.
Yeah. The third aspect in handling a disease like this, particular viral disease, is vaccine. Though we don't have much time, can you tell us in brief what's the kind of effort that you are putting to develop a vaccine?
Yeah, so dengue, as I said, dengue vaccine has been very elusive. For past 70 years, I think people have been working on dengue vaccine. And one of the French companies, Sanofi, also worked on dengue vaccine. After 20 years of work, and we salute Sanofi for staying with this despite dengue not being their problem. Their aim was to look at the travelers and pediatric population. They have now one vaccine for dengue is approved. This is world's first vaccine, but it has some limitations. The target population, and you could have some concerns of vaccine induced higher severe disease. So there WHO says that you do need alternative next generation dengue vaccines. Once again, through DBT, through Indo-US Vaccine Action Program, to help from Wellcome Trust, through help from ICGEB, we have a virus-like particle for which is made in yeast. And if you isolate this virus-like particle, which is based on the modern knowledge about the dengue virus, it does not take the whole dengue virus. The mantra for dengue vaccine is the less is more. You don't need to give a lot of immunogen, but take away that part of the immunogen, which is the business end of the virus. So once again, we have signed and filed an international patent, signed an agreement with Sun Pharma, and Sun Pharma, as I said, that has presence in several countries. We are taking all the international help to jumpstart to produce this under GMP, go through the talks, go through the phase 1. So it's a long way, it's an expensive way, but I think this marriage between ICGEB and Sun would make it happen.
It's a very, very interesting conversation. We had a wonderful discussion and also understood the kind of work that you are putting up to face this challenge of dengue. And of course, this institute and your team has also been working on many other areas. For lack of time, we cannot spend on those issues. We'll have to end this conversation here. Keep watching Eureka. We'll come back with another interesting conversation next week, same time. Keep watching Eureka.